Hello everyone. So in this lecture we will be discussing about the dynamic programming approach to our numpaths problem. In the earlier lecture we discussed about the recursive solution to it, but we saw that it has overlapping subproblems and optimal substructure. So in this lecture we will just try to optimize it with the help of dynamic programming and specifically with the help of tabulation method. So we will go again bottom up and we will see how can we optimize it. So before going on to the dynamic programming approach, I will just need to see that what were we actually branching out. What was this branch? This branch told that if I am currently sitting on 1,2, then I can go down and I can reach 2,2. The same way, what did this note say? That I am currently sitting at 2,1 and if I just go down, then I can reach my 2,2. So again, this subprogram specified that just tell me that what are the total number of ways to reach 2,1 from source. And the same way, this numpath 1,2 specified that okay, just tell me what are the total number of paths to reach 1,2 from source node 0,0, and whatever that might be, that would be my answer to 2,2 after adding these both branches. So the same thing we will do in our dynamic programming approach as well, and with the help of recursive tree which we saw now, we have made a reconciliation for that in one branch I would be recursing for one earlier row but in the same column, and in one branch I will be recursing for the same row but in previous column. So what does this subproblem say? That this subproblem says that currently I am sitting at 0,0. So just tell me what are the total number of ways to reach 0,0 from source. So this is again a base case. So what did we do over here? We returned 1. And why did we return 1? Because if currently I am sitting at 0,0 and I am asking that okay, what are the total number of ways to reach 0,0 from this node itself, then it would always be 1 over here. Now what does this subproblem say? This subproblem says that I am currently sitting at 0,1. Just tell me what are the total number of nodes or the total number of paths to reach 0,1 from source. So if I see over here, what did we branch out for? We branched out one time for 0,0 and again one time for -1,1. But I see that I do not have this matrix cell. So my answer is just dependent on this thing. And why my answer is just dependent on this thing? Because 0,1 is present in the topmost row. So I do not have even a single row above it. So in no way I can have a cell that if I come down from that cell I can reach 0,1. Again, I do not have anything above 0,1, and hence there is no cell in which I can come down from that cell and reach 0,1 because 0,1 is itself present in the topmost row, and hence in all the elements over here of the topmost row, the answer will be dependent only on the left hand side thing, because the left hand side node can be reachable, or this node can be reachable only through this node 0,1, because if I go right of this node then only I can reach 0,2. The same way, if I go right of this node then only I can reach 0,1. So I do not need to be bothered about one branch. I would be bothering about only the branch in which I am receiving my path from my left hand side. So in the case of 0,1, what is the value present at its left hand side? It would be 0,0. So what is the answer to that? It is 1. So 1 plus 0 would be 1, and hence my solution to this would be again 1. And what does this 1 specify? This one specifies that the total number of paths to reach 0,1 from source 0,0 is 1. The same way, what is the total number of ways to reach 0,2 from 0,0? Again, what I need to do is I need to come from right hand side. So there should be a cell present in 0,2's left hand side, such that if I come right of it or if I go right of it, then I can reach 0,2. So in that case, what cell I would be recursing for? I would be recursing for the same row but one less column. So I would be recursing for this thing 0,1. And what would I be recursing for in a case that if I come down of that node then I will reach 0,2? It would be this. But as I do not have this node in my matrix, so this won't even bother us. So whatever the answer to this 0,1 would be, the same answer would be to 0,2, and hence I can see that 0,1 is this subproblem. The answer to this is 1, and we would be having 1 over here as well. Now what is this subproblem? The intersection of this 0 and this one. It is this subproblem. So what do we have over here? This is the leftmost column. So can I have anything to its left that such that if I go right of that cell, then I can reach 1 comma 0? Again, do I have anything to its left? No. And if I do not have anything over here, so can I achieve this node that if I come right of this cell, that I can I can reach 1 comma 0? No. So I cannot have anything over here. So what would be my answer dependent on? The answer would be dependent on only the node that from which if I come down, I will reach 1 comma 0. So in this case, it would be 0 0. So whatever the answer would be for 0 comma 0, the answer would be there for 1 comma 0. Again, if you want to see it via a recurrence relation, so what do we have over here? I would be recursing for this thing 0 comma 0, sorry, 0 comma 0, and plus the number of paths to reach this node from source, and that would be 0. I have done 0 comma 0, and that would be minus 1 comma, sorry, that would be minus 0 comma minus 1. So can I ever have 0 comma minus 1 over here, or sorry, 1 comma minus 1 over here? No, I cannot have it. And why I cannot have it? Because this is my leftmost column, and hence whatever the answer would be to 0 comma 0, that would be the answer to 1 comma 1 comma 0, because I do not have a such cell in my matrix. So what is the answer to 0 comma 0? It would be 1, because this is a sub problem of 0 comma 0, and hence this would be my answer. The same way the answer to 2 comma 0 would also be 1 over here. And what does this 1 signify? All these ones signify that the total number of paths to reach these nodes from the source 0 comma 0 is 1. So if we just try to implement all these base cases, so what would I be doing is I would be populating my first row to 0, and to do that I would be populating it with the help of this for loop. And what can I do over here? Again, what does this one signify? That the whatever elements are present in first row, or whatever the sub problems are present in the first row, all of the sub problems would be having an answer of 1. And why 1? Because the total number of paths to reach that node from source 0 0 is 1 over here. So the same way I would be doing it for first column as well, because what does first column say? That the total number of paths to reach the sub problems which is present in the first column, they are also 1, because I can only reach them if only through the node which is present above them, because there is nothing on to their left. So we would be doing the same thing for this as well. So we are done with our base cases. Now how do we fill our remaining cases? Okay, now if we come on to these cases, so what does this cell signify? What does this subproblem? This is this subproblem 1 comma 1. So how would I be recursing it for? Again, I will check that is there a node present above it, so that if I come down of it, then I can reach 1 comma 1. Yes, it is present. And what is that node? That is 0 comma 1. And is there a node present to left of it, that if I come to right of that left node, that I can reach 1 comma 1? Yes, there is. And what is that node? That is 1 comma 0. So what does this recurrence relation say? That the total number of paths to reach 0 comma 1 and the total number of paths to reach 1 comma 0, if I add those up, then that would be my answer to 1 comma 1. So where can I find this subproblem in my matrix? That would be this one. So the answer to this subproblem is 1. And what is the answer to 1 comma 0? Where can I find it in the matrix? I can find it over here, the intersection of 1 comma 0. So what do I have over here? Again 1. So this would be 2. The answer to this subproblem is 2. And what does this 2 signify? This 2 signifies that there are total 2 paths from source with which I can reach 1 1. So if we see in the matrix, I have 1 1 over here, I have my source over here. So what are those 2 paths? Those 2 paths can be 0 0 0 1 1 1. So what those 2 paths could be 0 0 0 1 1 1, because look, this is the same subproblem we are recursing for in matrix as well. 1 comma 1 1 comma 1. So what are the paths? 0 0 0 comma 1 and 1 1. And what is the other one? 0 0 1 comma 0 and 1 1. And hence the answer is 2 over here. The same way, what is this subproblem? This one the intersection of this one and this two, again it would be that what are the total number of paths I can reach 1 comma 2 from source. So what would I be doing over here? Again I would be saying that is there a node present above it, so that if I come down from that node I can reach 1 comma 2. Yes, there is a node present. And what is that node? That is 0 comma 2. And if there a node present to left of it, that such that if I come right to left of that node, then I can reach 1 comma 2. Yes, there is a node present. And what is that node? That is 1 comma 1. So what is the answer to 0 comma 2? That is 1. This is 0 comma 2, the intersection of this is the sub problem. Now, and what is the answer to 1 comma 1? The answer is 2. So the total number of ways is 3. So I have a 3 over here. And what does this 3 signify? This 3 signifies that the total number of paths to reach 1 comma 2 from 0 comma 0 or from source is 3. So I need to reach 1 comma 2. So I can reach either this way 0 0 0 1 0 2 1 2, either this way, or I can reach either this way, or I can reach either this way. So there are 3 paths: 1, 2 and 3, and hence this 3 signifies this thing. So I think now we know how to populate our DP matrix, or the leftover cells in our DP matrix. So I think we should move on to that. So what is my recurrence relation over here? The current value of the cell would be equal to the answer to the cell just present above it. So how do I denote that subproblem? By just going one row above in the same column. So what am I doing? I am recursing for one less row but in the same column. So if it is 1 comma 1, so I am recursing for this 0 comma 1 over here. And what is the other problem which I need to recurse for? I need to recurse for this 1 comma 0. Then what would I be doing over here? What would be the answer to my this subproblem? I and j minus 1. What does this say? That I am present in the same row but one less column. And what does this subproblem signify? The subproblem which is just to left of it. So I would be adding these both, and that would be my answer to current subproblem. So I think now we can check our DP matrix, that how does it look and what are its contents. So yes, it got built. Now we will check our DP matrix. So the answer comes out to be 28. And what is the size? Yes, the answer comes out to be 28. And what does this say? That I have a matrix of 3 rows and 7 columns. So what are the total number of ways to reach the bottom right from top left? So I think it would be better if we do this 3 3 and we just uncomment our this debug macro so that we can see the contents of our DP matrix. Okay, we have an error. Yes. So what do we see over here? These are the contents of our DP matrix. So whatever DP matrix we populated here, 1 1 1 1 2 3 and 1, the same thing we can see over here as well. And what is this 6? This 6 is the intended problem. Look, what would be the intersection of this 2 and this 2? That is 2 comma 2. So what does the number over here, what does that signify? That signifies the total number of paths to reach this bottom right node from 0 comma 0. And in our case it's 6 over here. And hence we can see that our DP we have optimized our recursive solution with the help of tabulation over here.